So notes today are going to be on linear programming. And the objective of linear programming is to find the minimum or maximum values for either a maximum profit, or you want to find the minimum cost when you're finding out kind of for businesses, and you want to find out, hey, what do I need to get to maximize my profit, or what do I need to do to minimize my cost? So we're going to use linear programming today to do that, to find the maximum minimum values. Now on the first example, I need you to draw this in with me. So on the first graph, I want you to go to point 0.5s. Okay, so 0.5. I want you to label 0, 0. I want you to label 4, 3. And then I want you to label 7, 0. Right? And what I want you to do is actually just connect those points. So like 0.5 is going to go to 4, 3. Again, that was 0.5. And then I'm going to draw a straight line from 4, 3 to 7, 0. And I'm going to have 0, 0. And what I want you to do is just shade in, pretend like we're in first quadrant. I want you to shade in the area here. All right. What your book's going to do for the first couple examples of homework is it's going to give you a graph. So it will give you what I have now completed. It will give you the graph with the shaded region and what we call kind of the corner points of my solution area. All right. So in the beginning, they're going to give it the graph to me, and when we later on, we're going to learn we're going to make our own graph, and after that, we're actually going to have to come up with our own equations. So to start, when I have this graph and I have my shaded in area with my corner points, what I want to do is I want to create a table so I can figure out what the maximum value for X and Y that I need in order for my profit, and this is the profit equation they gave me. I'm going to plug that in my objective function and say, hey, which value is going to give me the maximum solution? All right. So what I want you to do is when you come up with your area, you're going to put in your corner points here. So in my first column, I'm going to put in, and it doesn't matter what order you put them in, I'm going to put in all my corner points and list them. Then I'm going to put in P equals 3x plus 2y, or whatever your function is. So in this example, I want to find the maximum of my profit, and they gave me the objective function to be 3x plus 2y. And what I'm going to do, I'm going to find out what my answer is when I plug in like 0 for my x and then 5 for my y. So I plug in 3 times 0, which is 0, plus 2 times 5, and I would get 10. And in this column, because of this problem, I'm looking for the maximum value. All right, so let's do the next problem. If I do 3 times 4 for my x value plus 2 times 3, I'm going to get 12 plus 6, and that would give me 18. Then I could do 3 times 7 plus 2 times 0. That will cancel. I get 21. And 0, 0, that's just going to be 0 plus 0. So once I've completed my table, I will look at my completed chart and say, okay, if I want the maximum value was at 7, 0, because 7, 0, and I do want you to come up with a phrase at the answer, phrase for an answer. You're going to say 7, 0 maximizes the function to be 21. And you could say something like 21 is the maximum when you use an x value of 7 and a y value of 0. So you don't have to write it exactly in those words, but you need to come up with an answer to tell the reader, hey, what x, y value is going to maximize it, and what would the maximum be once you do that. Okay? All right, so let's scroll down to part B. Now I have to graph, and then I have to find the x and y values that maximize or minimize the objective function. So if you look at the example here, I have 4 different inequalities, and I'm going to have a maximum function. So I'm going to go ahead and graph x is less than or equal to 4. That's going to be a vertical line at x is 4. Sorry, I'll try to make that a little neater. Okay, and I'm going to shade this way, so I'm just going to kind of shade it lightly for now. Y less than or equal to 5 is going to be a horizontal line, and I have to shade less than that. X greater than or equal to 0 is going to be a vertical line at 0, so I'm here and I'm greater than. And y greater than or equal to 0 is going to be the x-axis, and I'm greater than that. So if you look, the overlap is going to be my rectangle right there. So you graph whatever inequalities they give you. You don't have to label your lines, but what I do need you to label on your graph is going to be my corner points. So I'm going to kind of make obnoxiously big circles, and we need to find out what those coordinate points are. All right, so I'm going to label, let's see, this is 4, 5, this is 0, 5, the bottom left looks like 0, 0, and the bottom right looks like 4, 0. So I'm coming up with my corner points by graphing my inequalities, seeing whatever my solution area is, and the corner points of those are what I'm going to plug into. So I'm going to put, I'm going to make my table where I'm going to put my corner points, and then I'm going to put my objective function, and then I want a maximum again, so I'm going to put that here. So I'm putting in my corner points here, again in any order, so I'll put 0, 5, 4, 5, 4, 0, and 0, 0. All right, and you're plugging them into the objective function that they will have to give you when you begin the problem. So I would do 5 times 0 plus 2 times 5, which looks like it'd be 10. If I do 4, 5, 5 times 4 plus 2 times 5, whoops, I don't know what I just did, but that's right, hold on. There we go. 5 times 4 plus 2 times 5, so 20 plus 10 is going to give me, it's all right, 5 times 4, 5 times 2, so 20, 30. Then I'm going to do 4 times 0, so let's see, so 5 times 4 plus 2 times 0, that will go away, I just get 20, and then 0, 0 is just going to give me 0. So once you complete your table, since I'm looking for a maximum value, I look at what coordinates actually gave me a maximum value. So you can say I have a maximum value of 30 at the point 4, 5. And that's it. So since right now we don't have any real-life application to our problem, it's just x and y values, we're just going to say when x is 4, y is 5, that's my maximum value. Okay? Now let's scroll down to the next problem. So now I've got inequalities, but I'm going to have not only horizontal and vertical lines, but I'm going to have a diagonal line. So when something is not, when you have multiple variables, like in this inequality, I want to solve for y. So if I solve for y, I'm going to say y is less than or equal to negative x plus 7. I can graph this as a horizontal and this as a vertical. So let's graph y less than or equal to negative x plus 7. When I'm graphing this as a review, I'm going to go up 7. That's my y-intercept. And then my slope is negative 1, so I'm going to go down 1 over 1. Okay, so graph that line. And I'm less than or equal to, so I'm going to kind of shade lightly underneath that right now. Then let's graph y greater than or equal to 4. Well, y equal to 4 is a horizontal line at 4. And what I'm going to do is now I'm graphing above because I'm greater than or equal to 4. X greater than or equal to 0 is going to be a vertical line. And if I'm greater than or equal to 0, I'm over here. So if I'm greater than or equal to 0, and I'm greater than or equal to 4, and I'm less than or equal to this, it looks like I'm this triangular portion right here. So shade that in dark so I know what your solution area is. And once you come up with your solution area, now you need to come up with your corner points. So my corner points, it looks like, are 0, 4, 0, 7. Now, you're on graph paper, so you're going to be able to tell this is 3, 4. Right? But if you were to not do this on graph paper, and I wanted to find out what this point was, well, I know for sure my y value is 4, right? Because that's where my y is intersecting. If you go back to your original problem and say, hey, if I have this diagonal line, and I want to know when my x is equal to, I don't know what I just did. Let's see. Undo. Here we go. When my x is equal to 4, what does my y have to be equal to? It would have to be 3. So this is where you'd get this point 3, 4 if you wanted to do it by hands. But using graph paper is much easier to determine your corner points. All right, so let's, now that we have our corner points and we have our shaded region, let's make our table where we're going to find out. Now this problem, be careful, I'm finding the minimum. All right, so I'm finding the minimum. So when I go to put in my corner points, and then I'm going to put my C equals x plus 3y, and then I'm going to put my minimum value here. Just make sure at the very end, I don't want to find the largest number, I want to find the smallest number. So put in 0, 7, I'm going to put in 0, 4, and I'm going to put in 3, 4. I'm going to plug them in my objective function. So 0 plus 3 times 7 would be 21. 0 plus 3 times 4 would be 12. And then 3 plus 3 times 4 would be 12 plus 3 is 15. So what I need to look at now is, since I'm minimizing the function, or that's my goal, I need to say which values, what x and y values are going to minimize my answer. So it looks like 0, 4 will minimize my function to be 12. So I can say 12 minimizes my function when x is 0 and y is 4. All right. I'm going to do one more with you. On example 3, now we're just combining where we have a diagonal line, and then if you see something like this, 3 less than or equal to x less than or equal to 5, that just means it's two vertical lines. You could have written it like this: x greater than or equal to 3, x less than or equal to 5. That's equivalent. It's just two vertical lines. But I like how it's written like this because it's going to kind of tell me, hey, I'm in between those two vertical lines when I go ahead and I do my shading. So let's start out doing vertical lines at 3 and at 5. Oops, that's not 5. And 5. And I know I'm going to be in between, like less than that and greater than that. So less than 5 and greater than 3. Then let's go ahead and do the same thing. Now I'm greater than 2. Y is greater than 2, and it's less than or equal to 8. Well, those are going to be horizontal lines at 2. I kind of have to fudge this one up here and put 8 right at the very top. Okay. So if I'm at 8 and I'm less than 8, so I'm down here, but I'm greater than 2, it looks like I'm in this rectangular region. However, now we also have a diagonal line. So I'm going to do this in blue just to kind of help you see it. Whenever I have a diagonal line or a multivariable inequality, I need to solve for y. So if I subtract x over, I'm going to get y less than or equal to negative x plus 7. So I need to go to 7 on my y-intercept and then go down 1 over 1. Draw in my line. And I need to be less than or equal to that. Well, if I'm less than or equal to blue line, and I'm greater than the vertical line and greater than this line, I'm actually this triangular region again. So shade in that region, and I need to find these 3 corner points. Okay. It looks like this first corner point is 3, 2. Then this one looks like it's 3, 4. And the last point over here looks like it's 5, 3. Sorry, 5, 2. 5, 2. Okay. I'm going to rewrite this up here just so I can make more room for my table. So now I'm going to make my table to actually calculate what the maximum value would be if this is my objective function. So again, put in your corner points, put in your objective function, and then I'm finding the maximum. So I have 3 corner points. I have 3, 4, I have 3, 2, and I have 5, 2. You're going to plug those into your objective function. So 3 times 3 is 9, plus 2 times 4 is 8. That would give me 17. 3 times 3 is 9, plus 2 times 2 is 4. That would give me 13. 3 times 5 is 15, plus 2 times 2 is 4. That would give me 19. So because I'm looking for a maximum, I'm going to say that 5, 2 maximizes my function. to be 19. All right, so on the homework tomorrow that we're going to work on just finding the maximum minimum when I'm given a graph, and then we're also going to work on graphing it on our own, coming up with our corner points, and then determining the maximum minimum function.